Hey, what's up everybody, and welcome back to this three-part video series on how to design plastic parts for injection molding using Onshape. Now, in the previous video, what we did was design this plastic part. It's a plastic cover, and we went through and added things like draft and shrinkage, features that you would commonly see when you're designing a core and cavity. If you weren't with us for that previous video, or if you didn't model up that part, don't worry, I've included a link down in the description to a shared copy of that part from the very end of the last video. And you're gonna need that because in this video, video 2, we're gonna design the tooling split or the core and cavity blocks using the geometry from that plastic cover. And then finally, in video 3, we're going to introduce some intermediate and advanced tools for people who are doing plastic part design. This will be things like split lines and linked variables and ribs and feature script, and we'll give you some next steps. Now, this is going to be a true step-by-step guide. You will be modeling, so make sure that you're logged into Onshape and make sure that you've got that plastic cover from the previous video. And along the way, if you've got any questions, please feel free to leave them for me down below in the comments. If that all sounds good to you and it sounds like you're in the right place, be sure to hit the like button, be sure to subscribe to this channel, and let's get into it here with a quick intro of this project. In the last video, we introduced this idea of a mold base, which is an assembly of plates that slide up and down so that you can inject the mold with your molten plastic, and so you can eject the part from the mold when it's done cooling. And we talked about how within this mold base, it's very common to mill a pocket here in this mold base that is the same size as your core and cavity block so that you can insert that core and cavity block into that pocket. So today we're going to design those core and cavity blocks. Now the question is, how do we create the core and cavity blocks from the original plastic part? And one way you might think of doing that would be to perform what's called a Boolean subtract. That means that we would have the original part, we would take that original part and then add a block of steel surrounding that original part. And then we would perform a Boolean command where we subtract the material of the plastic part from the steel plate. And although this will work when the geometry is very simple, you'll start to run into problems as the geometry gets more complicated. For example, let's say we put a simple hole in the bottom of that plastic part. Then we do the Boolean subtract. Well, now we're not going to be able to separate the cavity and the core because that hole is going to create kind of a bridge where the steel remains connected. We're going to have to figure out a way to separate that steel. So instead, a very common workflow is to utilize surfacing. And in today's example, this is going to be very simple surfacing. So even if you don't have any surfacing experience, don't worry, I'll take you through all the steps. Eventually, you'll get into kind of complicated surfacing when you're doing this tooling splits on non-linear parting lines and non-planar parting surfaces. But for today, it's going to be very simple. And the idea here is that we create surface modeling with an offset of 0.00 millimeters, and then we extrude the core up to that parting surface. So what does that mean? Well, if you imagine the original geometry of the part, and then you imagine going in here and creating a surface which is offset at 0, 0, that's going to be an exact copy of that kind of inside surface of the part. Now, when we get to this hole, what we can do is we can kind of plug that hole with what's called a fill surface. So we just kind of create a planar surface running right over that hole, or a fill surface, and that's what we're seeing here. And then when we get to this top ledge of the model, we can extend that surface out. And the reason we're extending that surface out is because we want to make sure that that surface is larger than the dimensions of our core block. And then we can take our core block and do an extrude up to part to run that core block right up to that parting surface. Now, when it comes time to do the cavity, we can't use the exact same surface because we need to account for the original plastic part. So the cavity is going to run here on the lower surface of the part. The core is going to run here on that upper surface of the part. So to create the cavity, once again, we would do surface modeling. We would do an offset of 0.00 millimeters, but this time it's going to be to that lower surface. And then once again, we would extrude the cavity up to that parting surface. And what this leaves us with is our core and cavity blocks. And you can see here that where those two surfaces were not touching, we're left with a void, which is where the plastic is going to flow into. That void is created from the geometry of the original plastic part. And so then when we're done, we can see that we end up with this core and cavity block, and we can take each one of these parts and we can export that to a step and hand it off to the machining team. So that's the basic idea of doing this using surfacing. Now, the one pro tip that I always give my students is get in the habit of renaming your items in the tree. Rename your tree items, because even though this is a relatively simple mold split, we still ended up with 20 or 25 features in the tree just from that mold split. And a lot of those features kind of land right on top of each other, like the surface that we use for the cavity and the surface that we use for the core. So what I do is I get in the habit of naming these features based on whether they belong to the cavity or based on whether they belong to the core. And that really helps me to kind of keep things straight as I'm going through the tree. Trust me, this will help you, and you will see an example of this in just a couple of minutes. So what we just did there was what we would call a manual tooling split. We did it manually using surfaces. The question is, does Onshape have an automatic mold split feature? And the answer to that question comes in the form of what's called feature script. Feature script is a programming language used to create custom tools and features in the Onshape CAD platform. And what this means is that you can take a class on how to use feature script. There's a link down below in the description to the Onshape Learning Center. And what you will learn is how to create a new feature that doesn't exist in Onshape. You make a new icon for that feature, it shows up on your toolbar, and you get a feature manager that shows up when you access that tool. So it's exactly like a feature that's already in the software, but it's something custom, something that you came up with that's going to help you solve a problem in your CAD journey. The thing that's really cool about feature scripts is that somebody else could create these feature scripts and then share them with you and with the entire Onshape community. And these are typically found in the Onshape forum. And this post that I'm showing a screenshot of here comes from Neil Cook. I'll include a link to this post down below in the description, but you can see here that there are mold tools available for all Onshape users, like mold stock, creating the shutoff surfaces, creating the parting surfaces, and then doing the mold split. So these tools are absolutely available to everyone, and this will automate the process. Today, we're going to go through and do it manually using surfaces, following the steps that I showed a moment ago. But there is an excellent webinar from Neil. This came out last year in August, and there's a link down in the description to this webinar explaining how to use these tools. So check that out down in the description. This is really a next step. I would encourage you to continue going through today's presentation, learn how to do this manually because it will absolutely help you, but then take a look at this webinar from Neil where you can learn how to use the tools found in the feature script automatically. So with that, let's jump into Onshape. Let's start this step-by-step guide on how to use surfaces to create a core and cavity block from our original plastic cover. So here we are in Onshape looking at the plastic cover part that we designed in video 1. Now, anytime you receive a model and your job is to create a core and cavity block for that model, it's important to take a moment and run the draft analysis on this model. I know we did this in the previous video, but this is going to be important anytime you receive a model. So we come down here to this protractor, we choose draft analysis. We're going to say our mold split direction is the top plane. We're going to say that our draft angle is 5 degrees. And then here for the entities to check, you're just going to click anywhere on the part. And what we're looking for here are any faces that are showing up in yellow or red. If we see faces in yellow or red, then this part is probably not ready to perform the core and cavity design or the tooling split on. The other thing that we want to notice here is where do the light blue and the dark blue colors come together. So in the case of this model, we can see that the light blue kind of comes up here and over and up and over. And that's going to be the geometry for our core. That's going to be the geometry that kind of comes down in here for our core. And then the darker blue kind of runs along the outside of the model. So the darker blue is going to run down and along the outside. Looks like this face here on the inside is also darker blue. So there'll be a little plug there. And then it's going to come down and on the outside again. So it's important to recognize where those faces are coming together. It looks like it's going to be right here along this outer edge. And that's going to help us when we're doing our surface modeling. So overall, I think this part looks good. It does have the appropriate amount of draft, so I'm going to hit the green check mark for draft analysis. I'm going to maybe also go into analysis and look at my thickness analysis. I know we did this in video 1. Here for the thickness analysis, you're just going to click anywhere on the part, and then you should see it calculating and coming up with the thickness of this part. I know we did the thickness analysis in video 1, but it's always important when you receive a model just to run through and do the thickness analysis and make sure that there aren't any faces that are extremely thin or extremely thick that are unexpected. In this case, we've got most of our faces showing up here in yellow, which is this 3.09, and then we've got this group of faces here showing up in this kind of blue-green, which is like the 1.54. We knew that was going to happen, right? We knew that we had created a lip and groove feature here. So it's not really unexpected. And we talked to the mold maker, and the mold maker said, that's going to be fine. This part will still fill properly. So it's all good. So we did our thickness analysis. We did our draft analysis. Maybe one more thing to look for. Here, I'll go back down to this protractor and I'll say turn thickness analysis off. Maybe one more thing to look for here would be making sure that the model has a scale factor assigned. So yesterday we did our scale for shrinkage. Here you can see I could grab this bar and drag it back. We've got our scale for shrinkage. If the model that you're trying to design the core and cavity on doesn't have a scale factor, you're going to have to go in and you're going to have to add that in. But our model has all those features, so I think we are good to go. I think we are good to proceed. So one thing that I like to do before I get started with the core and cavity design is just kind of clean up the tree a little bit. Sometimes what I'll do is minimize the default geometry. So I'll click on this little arrow here. And then what I'll do is I'll click on the very first feature in the tree, and then I'll hold Shift, and I'll click on the last feature in the tree, and then I'll let go of Shift, and I'll right mouse button on that last feature and say Add Selection to Folder. And from here, I could name this folder. I'll call this Original Part Geometry. Original Part Geometry, and we'll hit the green check mark. And now you can see that what happened is everything that was from the original part got added to that folder. So now all my new features will be part of the core and the cavity. Now there are other ways to accomplish this. You could take the original part and you could insert it into another part studio, add it to an assembly and design the core and cavity inside the assembly. There's a lot of different ways that you could accomplish this. We're just going with the most simple way for today's video, just to kind of keep the presentation flowing along. But just keep in mind, this is not the only way to design that core and cavity. So now we've got all that original part geometry here in this folder. We've got that folder minimized. Let's start getting in here now and adding our surface geometry. Now, when you're creating surface geometry, you are going to be creating additional bodies or additional parts here in the part studio. So it's also beneficial to rename the original part. I'm going to go here to this original part. I'm going to press Shift N to rename that part, and I'm going to call this plastic cover. And we can also right mouse button on that original part and go to Edit Appearance and just change the color of this part to something that's going to stand out a little more easily as we begin designing additional parts in this document. And so now we are ready to start adding in our first surfacing feature. Now, when we were talking about that simple example, we introduced this idea of what to do when there's a hole in the model. And when there's a hole in the model, you have to create what's called a shut-off surface. And that shut-off surface is going to take place along the edge where the positive draft comes together with the negative draft, or where the A side and the B side come together, or where the dark blue and the light blue faces come together when you do that draft analysis. So it's a little hard to see here, but the dark blue face is down below here, and then the light blue face is up above here. So that means that our shut off surface is going to be applied here on this edge, kind of on the inside of the part. And the way that we create that shut off surface, let me close out of this draft analysis. The way we create that shut off surface is by using what's called a fill surface in Onshape. Now the surfacing tools are up here on your Onshape toolbar. I can never seem to find them myself, so I tend to just go to search tools, and then I will search for fill, and here you can see the fill surface icon. So I'm going to choose fill here, and this is a fill surface. It's going to be a new fill surface, and I'm going to pick edges for this fill surface, and it's really just going to be one single edge. It's going to be this edge right here. And when you're done with that, you can hit the green check mark. You can right mouse button on the front plane and say section view. And then you can really get a good view of what that fill surface is doing. So it's just creating a planar surface, connecting that surface all around that circular edge, and leaving us with a nice shut-off surface for our core and cavity design. Now, up here in the tree, I will rename that. I'll click on where it says fill 1, Shift N, and I will rename that to shut-off surface dash hole. And then down below here, I will also rename that. So this is its own part now, the surface 1. I'm going to rename that down below. So you can see currently I have 2 things selected. Remember, you can press the space bar to clear your selections. And then you can come down here to surface 1 in the Parts Studio, and you can press Shift N, and you could call that shut off surface. And the reason that's beneficial is because now we're going to start creating our surface offset at 0. And for that surface offset at 0, we're going to pick this surface as part of that surface offset at 0. We're basically going to make a copy of that surface to use as part of our cavity shutoff surface, and we're going to make a copy of that surface to use as part of our core shutoff surface. So it's good to kind of have that named explicitly. It makes it much easier to show and hide that as needed. So now what I'm going to do is I'm just going to press the letter P on my keyboard. P hides all the planes, makes it a little easier to make our selections. And now we're going to choose to take a surface and do what's called an offset surface. So again, you could come up here and you could use your search tools, or if you can find your surfacing tools here in your toolbars, you'll find that offset surface is in here as well. Offset surface, or just go up to your search here and you can search for offset. And there you go, offset surface. So what an offset surface does is it lets you pick a face off of the model, and it lets you offset that face to a certain distance, generating a surface. So you can see here in this example, what I did was I just picked this sidewall face here, and I chose to offset it to a distance of 5 millimeters. And that creates a new surface. A surface is a theoretic entity. It has no thickness. So surfaces, just a real quick review here. Surfaces are theoretic. They don't exist in the real world. They have no thickness. They have no volume. And they are used to help construct things, help with construction. They are construction geometry, just like planes are construction geometry. They're used to help construct things. You don't typically end up with just a model filled with surfaces. You end up with a model filled with solids, but you use the surfaces to help with the construction of those solids. So that's just a basic overview of what surfaces are in 3D CAD modeling. Now, we're not going to use that side face there, so let's just click this X here to clear that, or press the space bar to clear that. And we're not going to use an offset of 5 millimeters. We're going to use an offset of 0 millimeters. So 0, enter. And then for the surfaces that we're going to be selecting here, we're going to pick all the surfaces that are running around the inside of the model here. And a really easy way to select all of them is to right mouse button on one of them, choose select, and then choose tangent connected faces. And you can see here that what happens is we get all the faces that are tangent to that face that we right clicked on. Then the next surface that we're going to choose is going to be this face here. So now we've got an offset surface of all those inner faces, plus this face here, which is on the ledge. Then we're going to do another right mouse button, select, and we're going to choose tangent connected faces. So that gets all the faces that are running around that upper ledge. And then we're going to pick this face here at the very top of the model, this planar face at the very top of the model. And then the final face that we're going to select is going to be this face here, our shutoff face, this face right here. We're going to offset that as well. So our shutoff face, we pick that face as well. And once we're done selecting all those faces, we can hit the green check mark. You'll notice this list is pretty long. Picking a lot of faces here to offset, but we can pick the green check mark here, and boom, there is our parting surface for the core side of this mold. Now, it's not really the completed parting surface yet. We have to do a couple of more things, but basically what we did was we made an exact copy of all the interior faces of this model and an exact copy of this shutoff surface here. So now what we can do is go over to the tree and we can hide, you click the little eyeball here, we can hide the part, the plastic cover part, and we can hide the original shut off surface. So we can see here that now we have this surface, which was all those offsets from the inside, and this surface here, which is the offset from the shut off. So now what we need to do is we need to extend this ledge up top here. We need to extend this ledge outward so that there's enough material in the surface to stop our extrusion. So sometimes what's helpful when you're doing this is to actually sketch up what the geometry of the extrusion is going to look like. And when I say the extrusion, what I mean is the core and cavity blocks. So here what I'll do is I'll go to the top plane. So here where it says default geometry, I'll just expand that menu temporarily. And then I'll click on the top plane and I'll press S, begin a new sketch, and then I'll press N to get normal 2. And now what I'm going to do is I'm going to create the geometry for the core and cavity blocks. So I'm going to press the S key. I'm going to choose the center point rectangle. And then I'm going to make a rectangle here that's vertical to the origin. Single click, move my mouse, single click again. And I'm going to type in the dimensions 110, enter, 140, enter. Then I'm going to press the S key again. And I'm going to choose to create a dimension. So S key, dimension. I'm going to create a dimension here between this point at the center of my rectangle and this point here, which is the origin. And that dimension is going to be 20 millimeters. And that is the geometry that I'm going to be using for my core block and for my cavity block. So now I can exit this sketch. I can come over to the tree here. I can minimize my default geometry. I can click on that sketch 3 and I can say Shift N, layout for tooling split. So now I know what the dimensions are for that tooling split. And that's going to be very helpful because now the next step that I'm going to do is I'm going to take this kind of ledge that's running around this upper surface and I'm going to extend it outward. And the tool that we use for that, if I look at my surfacing tools here, the tool that we use for that is actually called Move Boundary. It lets you extend or trim the boundary edges of a surface. So I'm going to choose Move Boundary from my surfacing tools, or you could look up here, you could type in Move. You've got this Move Boundary. And for the Move Boundary edges, I'm going to right mouse button on one of these edges here, kind of like the outside perimeter up at the very top there, up the very top under that ledge. I'm going to right mouse button on one of those edges, and I'm going to choose Select Tangent Connected Edges. And you see what that does is it rips around that entire model and it gets all of those edges that are running around that entire model. And now what I can do is I can press Shift 5, which is the shortcut for top view. And then I can just grab this arrow here and drag this arrow until I have enough material here to stop the extrusion of my tooling split. So this rectangle that we drew a moment ago, now we see that our extended surfaces are large enough. If I made the surface like this, I might have a problem when I try to extrude that up to the surface because the surface isn't going to terminate the extrusion. But if I just take this arrow here and just drag this out, there we go. Now we are covering that entire tooling split. So let's just call that 50 millimeters, 50, enter, enter, and yeah, that is looking good. Now, you'll notice that we still have 2 different surface bodies. If we look down here, we still have these 2 different surface bodies. So let's do a Boolean command. The Boolean command is this one here, the 2 kind of overlapping circles. Let's do a Boolean command. And from this Boolean command, we're going to choose union, and we're going to pick one surface and then pick the other surface. And now we can click the green check mark, and those 2 surfaces are combined together. And now all we need to do is some tree cleanup. So if we go up here to this offset surface, we can click on that offset surface. We can press Shift N for rename. We can rename that to core dash offset surface at 0. We can go to the second feature here, this layout for tooling split. That's just a sketch that we're using, so we can actually drag that up here above the core just to kind of keep the core features separate. We can go here to this Move Boundary. We can press Shift N and call that core, extend, surface for tool split. And then finally, we can go here to this Boolean. So click on that feature, click on the Boolean, Shift N, and we can call that core dash, and let's say we name this one combine surfaces. And then you can click in the background. And then down here in the part studio or in the part list, we can go down here to this part list and we can press Shift N and we can call this one core tooling surface. And that leaves us with one final step, which is to take this sketch, the layout for the tooling split, click on that sketch, and then choose the extrude command. Extrude. Now, currently that sketch is down here on the top plane. So let's choose a starting offset for that sketch. Starting offset, and we're going to make that starting offset 50 millimeters. So now that is where the tooling split is going to begin. And then we're going to reverse the direction of that tooling split extrusion. So we offset it here, offset to 50 millimeters starting offset. That way we offset the sketch here where the extrusion begins up to here, actually up to here. And then what we're going to do is we're going to reverse the direction of that extrusion so it's going down. And we're going to say we want that to go up to part. And the part that we want that to go up to is going to be this part here, the core tooling surface. And so now if we hit the green check mark, that finishes that extrusion. We could rename this one here. You could press Shift N and you could call that solid core block or core extrusion, something like that. But that's that solid extrusion for that core block. Same thing down here for this part down at the bottom. You could rename that one. You could call that one core block. So it makes it very easy when you're getting in there and you're trying to hide and show those different features. And now if we were to hide the core tooling surface, you can see what we did with that extrusion. We extruded that right up to the plastic cover. If you show the plastic cover again, you can see what that looks like. If you right mouse button on the front view, front plane, so if we go in here to our default geometry, right mouse button on the front plane, we can say section view, and then we can really clearly see what's going on with that core block. I'll hit the green check mark here. You can see how that core block is extending all the way up to the part, right up to that parting surface. And that is exactly what we do when we are using surfacing tools to design tooling for our core. So now I'm going to right mouse button in the background. I'm going to say turn off section view. I'm going to minimize that default geometry. And now we are going to move on and do the same thing, but design the surface geometry for the cavity. Now, to get ready to design the geometry for the cavity, we are going to start by hiding the core block and showing that shutoff surface down at the bottom of the part. So there we can see that shutoff surface. We're going to rotate the view so we can look at this thing kind of looking in from the bottom. And then we're going to choose the offset surface command. So again, you could search here for your tools, offset, or you could choose offset surface from your toolbar. Or if you're doing a lot of mold design, you could even press the S key and then right mouse button and choose customize and add the offset surface command to your S key menu. But I think what I'm going to do here is I'm just going to go in and I'm going to choose search tools, search for offset surface. And here we go, offset surface. The offset distance is going to be 0. I will pick this surface here, the surface from our shutoff surface. I will pick this surface here, which is the side wall that's drafted up for that hole. And then I will right mouse button on this surface and I will choose select tangent connected faces. And so we see that rips around and gets all the remaining faces. And that takes us right up to this edge here, which we identified earlier as the edge where the two surfaces come together. So that's it for this surface offset. So I've got all those surfaces selected. It looks like it got all the surfaces all the way around. So I'm going to hit the green check mark and oh yeah, that is looking good. So now, just like we did last time, we could come over here and we could choose to hide the plastic cover part, and we could choose to hide the original shutoff surface. So there we go. Now, last time when we got to this phase of the design, we used that command move boundary. Well, move boundary isn't really going to work this time because move boundary is going to be like an extend command. And to see that, if I choose move boundary and then I choose this edge here, you can see that what's happening is that surface is being extended up in this direction. Sometimes we want to use that. Sometimes that's very useful. But in this application, we want that surface to kind of kick off to the side here, kick out this way. We really want it to be parallel to the top plane as we're creating that surface. So instead of using move boundary, we're going to use what's called a ruled surface. So we will search for ruled, and then here you can see we can pick ruled surface. Now, ruled surface is a very powerful tool. It's got a lot of different applications, but the default one here is normal. And to illustrate what normal does, we will pick on this edge right here, this edge running right across the top of the part. So you pick on that edge running across the top of the part, and then click in the background and then press Shift 1. Shift 1 takes you to a front view, and we can kind of see what's going on with this ruled surface set to normal. So the distance here is set to 25. That's the default distance, and that means that the length from here to here on our new surface is going to be 25 millimeters. And then the fact that it's set to normal, ruled surface type normal, and the angle is 0, means that we're going to take this sidewall that's running up this way and then kick off our surface at a perpendicular angle. Now, that's really not what we want. We really want that new surface to kind of be running up flush to the other surface that we had created in the previous step, to our core surface. So we're going to end up with kind of an angle here between those two surfaces. That's going to be no good. That is not what we want. So instead, we're going to set our ruled surface type here to be angle from direction, and then Onshape is going to ask us to pick a direction, and the direction that we're going to pick is going to be this flat surface here at the bottom of the model. And so now we can see that what's happening here with this ruled surface, if we go back to Shift 1, now we can see that that ruled surface is kicking off normal to or parallel to that surface down at the bottom. So we did an angle of 90 degrees. Really what's happening here is Onshape is taking that surface down at the bottom and it's creating an axis running up perpendicular to that surface. And so that way we can have this normal surface run all the way around, and it's always going to be running off normal to that axis, or 90 degrees relative to that axis. So here where it says edges to offset surface, we could go around and pick all these outside upper edges, or we could right mouse button on one of those edges and say select tangent connected edges, and then that will go around and pick all those outside edges. And so we can see here that we're not seeing a preview of that ruled surface, and the ruled surface is also showing up in red here in the tree. That means that there's going to be a problem, but it also looks like the arrow for the ruled surface is pointing inward. So I think all we need to do is just click on this button here for reverse direction for our distance dimension. So reverse direction, and oh yeah, there we go. That worked. Now, sometimes when I'm doing ruled surfaces, if it still doesn't work, even when I flip the direction here, I'll switch over to creating a new surface, and that's going to create a new part down here. But it doesn't really matter because in a minute, we're going to do a Boolean anyway and combine all these surfaces together. So that's just a little pro move. If you're ever in a situation where add doesn't seem to show you the preview, or it seems like it's erroring, maybe try using new and see if that works a little bit better. In fact, in this example, I am going to use new just to reinforce that lesson because it's gotten me out of a lot of jams when I'm creating these ruled surfaces. So we're going to choose new up top here. We're going to flip the direction of this arrow until the preview looks good. And then we can go up here in our tree and we can choose to show the layout for the tooling split. So you click the little eyeball there to show the layout for the tooling split. Click in the background and you can choose Shift 5. And then you can increase this distance, or grab this arrow here, increase this distance until the tooling split is being covered by this new ruled surface. So again, we could maybe go with a 50 millimeter distance there. That looks like that should be enough for that tooling split. And if that all looks good to you, you can hit the green check mark and boom, there you go. You created that ruled surface. And so now we're ready to jump into the Boolean command to combine all these surfaces together. You know, in some CAD packages, they call this command knit or knit surfaces, but in Onshape, what we do is we use the Boolean command. So here's the Boolean command up here. And then for our surfaces, I think a lot of times it's easier just to come down here into this parts list and 1, 2, 3, merge all those surfaces together, or knit all those surfaces, or union using the Boolean command, and we hit the green check mark, and there we go. Now we just have that one single surface. So now we just need to do some tree cleanup. We come over here to the tree. We could hide that sketch, which was the layout for the tooling split. We can come down here to this offset surface and Shift N, and we're going to call that cavity offset surface at 0. And then you can click on that surface so it's no longer selected. And then you could choose this ruled surface here, and we can press Shift N, cavity. This will be, I'll just call this one extended surface again. Extended surface for tool split. And then this last one here, so click this, Shift N, and this one is going to be called cavity combine surfaces. And so now the tree is very easy to read through. You can click in the background so nothing is selected. You can click down here on this part, this surface down at the bottom here, and Shift N, and we will call that one Cavity Tooling Surface. And that will make it much easier when you're going through and you're navigating your tree. And so now the final feature for the cavity is to just extrude the solid. So we're going to click this layout for tooling split in the tree. We're going to click extrude, and that should show us a preview of that extrusion. Currently, this is directly on that lower surface. So let's give ourselves an offset here. So starting offset, let's make that 25 millimeters, and we can click this reverse direction to have that starting offset go down below the model. And then for our direction here, instead of blind for the end type, we will say up to part, and we will click this part here, and look at that. That's looking pretty good. We hit the green check mark. We can hide that cavity tooling surface. So hide down here, the cavity tooling surface. And then in the tree, we can come over here. We could rename this feature. So Shift N, we'll call that solid cavity block. And then we can come down here to this part down here in the parts list, and we can click on that, Shift N, and we can call that one cavity block. And so we can see here now, if we show the plastic cover again, and then we go to our front plane, right mouse button on the front plane, section view, we can see what that cavity block is doing. It's coming right up to that plastic part, and that is where the plastic is going to flow. It's going to flow right up to that cavity block, and it's filling in this hole here because of our shut-off surface. And so if we also show the core block here, we can really get a good feel for what these two components are doing and how they are coming together directly on that plastic part. And remember, we did add a scale feature to that plastic part. So this cavity that we're creating, if we hide that plastic cover, this cavity that we're creating with these two components should be scaled up so that when the plastic part cools in the mold, it shrinks back down to the correct size. And now there's just a few final topics I wanted to talk to you about to kind of round out this lesson. And it's kind of funny that I use the term round out, because one of the first things I'm going to talk to you about is rounding out these corners here on the core and cavity block. So let's start by doing a right mouse button and saying turn off section view. And a lot of times these blocks are rounded off so that they can fit into that pocket that's milled into the plates in the mold base. Well, the cool thing about Onshape is that we were able to create this layout for tooling split as one single sketch and then use it for both our core and cavity blocks. And that means if we double click on that layout for tooling split and then go to the sketch fillet command, we can apply fillets here on these four corners. So I just picked these 1, 2, 3, 4 corners, and we could say that we want that fillet to be 15 millimeters in radius, and then we hit the green check mark, and now look at that. Both our core and our cavity block are both reflecting those fillets. Now, another thing that you may want to do when you're either looking at this core and cavity block yourself or showing it to a customer is kind of show it in an exploded view. A really easy way to do that is just to use the transform command in Onshape. So if I show the plastic cover again here on the inside, so all three of these solids are shown, I can then go up here and search for transform. Remember, we used this when we did the scale on the plastic part in the last video. Well, this time when we do transform, we're going to say transform by XYZ. And when we do transform by XYZ, we can then click on this upper plate here, grab this arrow, and just drag it up. It's almost like you're making an explode view. You can hit the green check mark here. Then you can go up to search tools again. You can see the transform is right there because it was recently used. So you can click transform again, click on the plastic part, choose to transform by XYZ, and then you can grab this plastic part here and kind of drag that up as well. And that way you can examine this yourself and maybe show it off to a customer so that you can see what's going on with all of the components in that design. When you're done with that transform, you could just click on those features. So click the one, click the other, right mouse button, and you can choose suppress, and now it's no longer transformed. So that's just a little trick that you can use when you're trying to see what exactly is going on with those blocks. And then another thing that comes up often is the surfaces themselves. Do we need to leave those surfaces behind? It's up to you. It's not really going to hurt you to have those surfaces in there, but it can sometimes be a little bit cumbersome to have all those extra parts in the tree. So what you could do is pick the first one, hold shift, pick the last one, and then right mouse button on any one of those, and you can choose delete. Now what this will do is it'll make a new feature in the tree called delete part. So you can hit the green check mark here. So now you can see that if you look at the tree up top here, the last feature was transform 1, transform 2, and then delete part. And if you were to take the rollback bar and roll back before that, then you would see that those surfaces now show up down below here. Those surfaces are there. And if you take that rollback bar and you roll it forward to after that feature, you can see that now those surfaces are no longer there. So that's something pretty common that you see when you're looking at somebody else's tree. If they've got surface modeling, there may be a feature here called delete bodies or delete parts, and then this would be the surfaces. And then the final thing that I wanted to talk to you about is how do we get these parts, these blocks out to our machinist? Well, it's very easy to do that in Onshape. You can simply come over here to that block. So simply come over here to the core block, right mouse button, and then you could say export. And what Onshape will do is it will take just that part, just the core block, and it will export it to whatever format you specify. Step is pretty common in the machining world, so you could export that to step. And then what you'll see is that down here, you've got this option for export and download. And so that's going to put it into your web browser and let you download that step. And that way you can hand that step off to the machining team. And you would do the same thing here with the cavity block. And so that is going to do it for that process of creating that core and cavity block and exporting those two steps so you can start getting those parts machined. Let's jump back into the presentation and just kind of cover the common steps that you'll go through so that you'll have a playbook, especially for those of you that are taking notes. The first thing that you're always going to do is identify where the positive and negative draft come together. And this line that I'm pointing to here is often referred to as the parting line. This is where your A side and B side come together, or where your core and your cavity blocks come together. And it can help you make decisions in some of the subsequent steps in this process. The next thing you're going to do is look for any holes or gaps that need to be shut off. And you're going to use the fill surface command most commonly. There are some other commands you might use, but usually you'll use the fill surface command to fill in those holes. Then you're going to launch the offset surface command and you're going to set the value to 0. You're going to go around and pick all of the faces that are on one side or the other of the mold, and you're going to stop where those two sides come together. So again, identifying that parting line, very, very helpful. Next, you're going to create a sketch for the core and cavity block perimeter, and these dimensions should match the cavity or pocket which was cut into the mold base. So that way you can just take your core and cavity blocks and slip them right into the mold base. Then you're going to extend those surfaces so that they fully cover that tooling sketch. You'll do this using move boundary or ruled surface, or even another command like extruded surface. It doesn't matter what command you use, you just need to make sure that that surface extends beyond the perimeter of that tooling block. Then you're probably going to have multiple surfaces that need to be knit together. So we're going to combine the surfaces into one single part using Boolean-Union. That's how we do it in Onshape. And now you'll have that one single surface, so you can extrude the tooling sketch up to part, and you can select that surface as the end part for that extrusion. And that will leave you with a solid core block, so you can right mouse button on that core block and choose export. You can choose to export that to step, and then you can download the step file so you can share it with your machining team. Once you're done with all those steps, you can repeat those steps for the cavity block. You can repeat those steps for any other inserts or slides that you have, and you should be good to go. That's pretty much it. So congratulations, part 2 of the tutorial is complete. Let me know down in the comments what you thought about this video. Let me know if you have any questions. Let me know if you like our style of training. And of course, the next steps for you are going to be to research the action items and examine the Learning Center links. I included some great information down below in the description, and to then continue on to video number 3. Be sure to hit the like button on this video. Be sure to subscribe to this channel, and I'll look forward to seeing all of you in the next video.